Oh, we need to do number 3, don't we? Number 3. All right, friends. First thing that we need to do here is write a balanced equation. So,
Yes, it is. I just always remember when I watched her at 4 a.m. and I was crying and my mom
guys. Hey guys. This is 1666, right?
Yeah.
It is. Guys.
Yeah, I'm ready.
Guys.
Hi.
Guys. Okay, it's important to me that you guys kind of understand how this works because the problems will get more difficult. So it's okay. We're going to be prepared when that happens. All right. So when we're making a BCA chart, what we're doing is we're making a table. You guys have made tables before, right? So the first row is our equations. And think about those as like the headings for our table. And then we're going to have a row for the stuff that we have before, a row for what change happens when the reaction happens, and then a row for what we have left over after the reaction. So this is my table. Kinda, but not really.
They made Barbies.
Okay. You guys see my table there? Table. Some folks in second period were asking me questions about this, so just want to make sure. Do you guys see the table? Isn't it nice? Wouldn't you think my collections?
Oh, you saying?
Aladdin. All right, so there's our table.
Okay.
What our problem says is you eat 180 grams of glucose. If glucose, sugar, I know you guys have already had too much glucose, reacts with oxygen gas to produce carbon dioxide and water, how many grams of oxygen will you have had to breathe in to burn the glucose?
Oh.
So, yeah.
Is that how you burn calories? What do I do?
No, it's a gross oversimplification. The way that you get rid of fat that you've burned though is by exhaling carbon dioxide. So the carbon dioxide in your breath is from calories that you burn, whether it's fat. Anyway, so
It's not COVID safe.
already? I don't know. We got to get through this, guys. All right. So the first thing that we need to do, because the only thing that we can put in our BCA chart is the number of moles of stuff. Okay. So what we're told is we have 180 grams of glucose. So if I've got 180 grams of glucose, and I want to know how many moles that is, what I need to use is my molecular mass of glucose that we calculated yesterday. So for every 1 mole of glucose, I'm going to say glue. For every 1 mole of glucose, we have a mass of 180.156 grams of glucose. So in our 180 grams, we're going to have, I think, a little less than 1. So here we've got 180 divided by 180.156, and it gives us 0.999 moles. Should we just round it up?
Oh, yes.
Okay. So, what?
Grace wrote "help me" on her whiteboard.
Oh, Grace, just work on your homework with us.
I don't have it. She did mine. Yeah, I don't know why.
Well, take it back and she can copy me.
Yeah, copy
Tammy.
her. No, because you're on the thing. So, for these, so like, I know, okay, so you can say like 6 things, right? So I
Okay.
have different numbers of 6 things, but it's like some of them, it's like if you round a certain way, you get a big answer. How are you gonna change like the test for homework? Like, does it have to be like around the general?
It needs to be close. Like,
Because, yeah.
don't give me that number.
Yeah, so I gave you like 0.999.
Yeah, it's
But
fine.
then you rounded like the number of the bottom.
I'm just trying to do that because I keep losing all of your guys' attention.
I know for other ones too.
We have our attention with you.
Can you imagine if the play was this way, Grace?
It kind of is. It is this way.
You guys up there doing your performance, and everybody in the audience is just like talking about something else. Okay.
It's kind of how it is, actually.
It's my life every day.
So to actually close.
People are like, why do teachers go home emotionally crushed? Be like, pass the chocolate cake.
You see that as you're over here, like,
Just look around at the teachers.
Like, it's not just us.
You didn't see my whole honeymoon.
All
All right, so we're being asked how many grams of oxygen do we have to breathe? So we're being asked like how much oxygen do we have to use? Some of you may be able to identify some of this already. But what we need to do is figure out how much goes here. The way that we do that is we use our balanced equation up here, and I'm running out of scratchy space. Okay, so if I've got 1 mole of glucose, the way that I'm going to convert that is I'm going to use my, these things are called stoichiometric coefficients. This guy, I know, but it's a real word and it's kind of fun. This. I mean, if you're going to learn the word stoichiometry, you may as well like use it. In front of this, it would be a 1. So I'm going to take my 1 mole of glucose and I'm going to multiply that by a ratio. For every 1 mole of glucose, I'm going to need to use 6 moles of oxygen.
Okay.
So that means I'm going to have a total of 6 moles of oxygen that gets consumed, right? So that's going to go here. 6 moles is what I use. How many grams is that? So I could go here, 6 moles. I'm going to do that times 32 grams for every 1 mole, right? And our moles oxygen is going to cancel. So if we do 6 times 32, like 6 times 2, 6 times 32 is 192 grams. Is that a little or a lot?
A lot.
It is a lot. I'm going to write that over here. 192. I'm going to just write that up here. 192 grams. Okay, how'd you guys do on that one? By the way, did you guys notice that all of the answers were at the end of the sheet?
Yes. Yes, I did.
Neat.
Please do not erase that one.
Why does it say Grace?
You guys, the struggle is real today.
No, don't erase it. I want to take a picture of it.
All right, next one. Zinc is reacting with hydrochloric acid. You shouldn't eat zinc like this. To produce zinc chloride. Guys, what's the formula for zinc chloride?
NCO. With the 2 at the end.
And hydrogen gas, which is what formula?
H2.
Is this balanced? No.
No, it's not.
But if you just have 2 of each,
Yeah,
then
there
you're
you
fine.
go. No, it's 1, 2, 1, 1.
Yeah, so that's it.
Yeah.
Okay. So for our BCA chart, we need our equation. We need a before, change, and after. And this is our chart. Charty chart. Do you guys understand that this is a chart?
Yes.
Yeah.
You said it enough times that we figured it out.
You'd be surprised at the actual amount that's like sunk into people. Okay. So
I didn't mean that in like a disrespectful way. I'm sorry. I didn't mean it.
Grace just didn't take that.
No, that was a genuine like. Oh,
It's just-
you said enough times it's processed in my brain. That was meant to be.
it's not everyone. All right. So we've got 4.61 grams of zinc. So what we have to do is figure out how many moles that is. So 4.61 grams of zinc. To do that, we're going to use our handy dandy periodic table.
And you add the numbers on the bottom again. What are those numbers called?
Atomic mass. Yeah. So our atomic mass for zinc is going to be 65.38. And that's grams per mole. So here I've got grams. I need to get rid of grams. So 65.38 grams.
That's a goal.
Why is Coach walking back and forth outside? You okay, Coach? Everything going all right?
I'm just gonna, after school, we're just gonna do a few of them.
I've just seen you walk back and forth.
I just had to make some copies of emergency medical form.
Ooh, exciting. Oh, they are a handful today, I'll tell you what.
My name is. Crystal. What's that?
My name's Grace.
Last name is.
Pete.
And I know your sister.
Yeah. I talked to you one time last year when you were subbing for English, and we spent the whole time talking on that. We already talked to her.
Oh, naps.
How do you remember it?
I'm an expert.
Yeah, well, see, because you think the nap is like half hour or less, and you're like, oh, these kids these days think nap is like 3 hours.
Naps are
Well,
like
that's not
2
a nap.
hours. It's like
That's
2
not a nap.
hours. 30 minutes is like a power nap. Like, that's a
That's
a subcategory.
is like 20.
Yeah.
I have taken a 3-minute nap before, because that's what I'm telling you, after 3 minutes, I just like really isolated.
Need to recharge a little bit.
Yeah, so I do know you.
Well, when you get to be my age,
Yeah.
you take it where you can get it. 5, 10, 15 minutes. You have to feel these two days.
At the same time.
Wait, what did you do?
Yo, what?
Why did you do that twice?
Chemistry, physics.
They're different. One is I was converting from grams of zinc to moles of zinc. And then I went from moles of zinc to moles of zinc chloride.
Wait. Does this method work too? Okay, so I did the first part. Like, I use what I have of zinc times the mole on top,
And then
grams on the bottom,
you go.
then I just take that and I do that. So this I just use the ratios like that is for 1 or 2 has to be that times 2. And then I feel like whatever's yielded isn't there yet, so 0.
Why did you use 2?
I did it. So what I did was I got this up here. So then since it's a ratio,
Yeah, this is the same.
that times that is for 1. So since this has 2 in front of it, this times 2 is that. So that's why it goes
But
there.
this is also going to be 0.14 because you're going to use them in a 1-to-2 ratio.
Okay.
So you have to have a 1-to-2 ratio, then you're going to use them in a 1-to-2 ratio.
So then I lose 0.14 moles of this.
Right, because it's all going to be gone.
Yeah.
So what's going to end up happening is that after here you have 0 moles of zinc left, you have 0 moles of this left, you've gained 0.07 moles of that, and you have 0.07 moles.
Okay. Yes, that's instead of like doing that, I just like multiply it to get the score for the ratio.
Yeah.
And then I take the zinc chloride to do this to get the theoretical.
Yeah, and
And then I do that. That works too. And that's just times 100. Because it says 100%. That's just like times 100, right?
Yeah.
Yeah.
Yeah, so your number here will actually be 0.89, and then you multiply by 100.
Wait.
This number is 0.89.
Maybe like round out the edges on the left.
0.89. And you have to do the times 100 to get the percentage. Because what that means is that if you have 100 parts, 89 of them, you got 89 out of the 100.
So this still works. Let's say my numbers are kind of off.
Yeah, that works. That's fine.
God awful.
That's like if Perry the Platypus was in Minecraft.
Can I please take out my phone and take a picture of that?
No, we have stuff we gotta get done.
Okay, after. Please do that. I'm begging you. Do not do that.
I mean, if you know it, I could just give you a quiz tomorrow.
No.
Stop your Gavin. We're trying to learn. Dr. O, I'm trying to pay attention.
Thank you, girls.
Good job.
This is so loud in here. Hmm?
I just like randomly said that.
What about it?
The effort for paying attention is there.
Yeah, I know. I just know that if I like don't force you guys to listen to me, then in a week you guys are all gonna be freaking out about something.
No, I listen.
Really?
I'm just really proud of myself.
Seth, I would like you to
I'm
stop.
very excited.
Like, you guys have computers open. I know for a fact nobody needs a computer open.
Uh-huh, that's exactly what I was thinking, Dr. Okay, I was doing.
I didn't, first of all, I know that I'm not paying attention. I didn't say anything. I've been drawing platypuses the entire time.
Yeah, but you keep showing everybody.
Just keep going with it, keep going.
I know, I just feel like I'm
didn't
talking
say
to an empty
anything.
room.
I don't know why I just.
I was like, I know I'm not paying attention. At least you're not trying to lie about it.
Okay. So what we're trying to do here is get to the point where we can calculate what our percent yield is. So if we did this equation, say, what if you were being paid to accurately collect all of the product and somebody needed to know how much you got? And this might matter with something like if you're making a drug, right? Let's pick a legal one like Tylenol. Like if you're making Tylenol,
That's not hard.
you need to make sure that you're getting
Okay, great, that's a whole different talk. Let's do chemistry.
It is chemistry.
I mean.
It's used in the wrong way.
Honestly though, chemists have one
Everybody's a chemist.
Separate chat.
there's Breaking Bad.
It's Breaking Bad.
All right, so what we're gonna do
That's a good question, guys.
What are you guys looking at? Huh. Okay. All right. So what we're going to have to do is use our stoichiometric coefficients to figure out how much we have. And the information that we're given here is grams, right? Because there's not really a way to measure moles. You have to calculate them based on the mass of something. So here we've got the mass of zinc, 4.61 grams, which I put there. And I'm going to convert it to moles using the atomic mass that I got from the periodic table. So we did that and we found that we had 0.04 moles of zinc, and that number gets put in our BCA chart. So that's how much we start with. And it asks us how much zinc chloride should we get. So in order to figure that out, we're going to need to see how much gets created because we're starting from a position of having none of our products. You know, in the future, we will start with some of our products, and so that will change it up. That's why you guys need to know how to use the chart. So what we need to do is figure out how much zinc chloride we have. And what I just did with my notes up here is I just used that product, right? Because that's where we would start with the next calculation. So I've got 0.07 moles of zinc times, for every 1 mole of zinc chloride I produce, I'm going to need to use 1 mole of zinc. And that tells me I've got 0.07 moles of zinc chloride. So that's how I went from zinc to zinc chloride.
But I don't understand that because if you have 0.07 moles of zinc and then 0.707 moles of zinc chloride, then there would be no chloride.
What do you mean?
Because
This is moles and not grams.
I don't know.
So this right here, this value is 4.61 grams, right? That's this
Yeah.
number. So the next thing we're going to need to do is figure out how many grams this ought to be.
Oh,
So-
I see what you. I
You tracking? So if I've got 0.07 moles of zinc chloride, I need to figure out what my molecular mass is. And so I think it's 138 something. So what I have to do is use 2 chlorine molecules, or 2 chlorine atoms. So I would do 35.453 times 2 and add to that 1 mole of zinc atoms. And I got 136.286. Oh no, I don't like this being here. I'll do it over here. So if I've got 0.07 moles of zinc chloride, I know that for every 1 mole of zinc chloride, my stuff is going to have a mass of 136.286 grams. So that means that of my product, I'm going to have 9.54 grams. So, Grace, that's the mass of our product, and we started with, for just zinc, 4.61 grams.
Now we can figure out how many grams each forming you have.
Yeah, but we don't need to.
Oh.
Because it asks how much zinc chloride should you get, and that's how much zinc chloride we should get. So that's our theoretical yield. That's like, if everything went perfect, that's how much I would have. But in the second part there, we're told, suppose that you actually recovered 8.56 grams of zinc chloride, what is your percent yield? So to figure that out, we're going to use our equation from yesterday. Our actual yield divided by theoretical yield times 100%. Well, it's a percent. So we were hoping for 8.54 grams. What we actually got was 8.56 grams. So when we divide those by each other, we get 0.89 something. 8.56 divided by 9.54. So then I got 0.897, and I'm going to multiply that times 100%, and I get 89.7%. What questions do you guys have? None questions? No, you guys are just being teenagers. You don't do it every day. If you did it every day, well, drama. Okay. Number 5. So number 5 says determine the mass of carbon dioxide that should be produced in the reaction between 3.74 grams of carbon and excess O2. What's the percent yield if blah, 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 O2 is recovered? So we've got carbon plus O2 yields CO2. Is that balanced? Yes. Yes, it is. So that's our equation. Then we're going to have before, change, and after. I feel like this one needed more space and this one needed less. Okay, so we first have to figure out how many moles we have. So for carbon, if we have 3.74 grams of carbon, carbon is 12 grams for every 1 mole. And I wrote it that way because I want my grams to cancel. Come back, calculator. 3.74 divided by 12. It's actually 12.011. 0.31 moles of carbon. So if I come back over here, the amount that I'm going to use is 0.31. We're told that we have excess O2, and we're going to start with no carbon dioxide. So now we need to figure out our theoretical yield of CO2. So if I've got 0.31 moles of carbon, which I get from this, and I need to convert that to moles of CO2, I know that for every 1 mole of CO2 that I produce, I'm going to use up 1 mole of carbon. And so my amount of CO2 is going to be 0.31 moles of CO2. So I'm going to use up all that carbon. I'm going to use up 0.31 moles of oxygen. So I'm going to have no carbon left, and I'm going to have gained 0.31 moles of CO2. If I try to figure out how much mass that is for my 0.31 moles, CO2, for every 1 mole of CO2, I've got 44 grams of CO2. So that's going to be 13.7 grams. But we only got 11.34 grams. So we figure out our percent yield. It's like a soundtrack.
Okay, but also, I have a whole, the meat song, whatever, became, a big popular thing. But I'm the only one that literally, when I'm like a 5-year-old, I would just have it on, so I could listen to it. I literally used to listen I used to listen to it over and over.
Which soundtrack?
Like, you know, like when all the bees are like in like the little room.
Wow, really?
Wow.
Wow. So the thing that I enjoyed about the whole Wii system is that when our friends would come over, we would like set up a me for them.
Yeah.
And so now when we go and play it, like our friends are in the audience. And we're like, oh.
Yeah.
I used to like go around to have when I like came to school. I used to go around and make every person in my class. And I just like, oh, the people in the group haven't seen like a long time. Like,
We have Caillou. He's really short, really fat, really bald. It's great.
What was also funny is my husband made his, and his me looks like Harry Potter. And so my daughter used to always be like, why is Harry Potter in our Wii?
In our baseball game.
And then I had to say things like, that's not Harry Potter, that's your dad. And she was like, she's like, my dad's not Harry Potter.
Go back to me and you're like, oh.
All right, guys, if you hadn't finished that already, finish it today, okay?
oh yeah. Oh, okay. I'm good.
You guys got this.
I think I kind of get ready for it. Oh, can I please take a picture of Harry Potter?
Wow. I mean, that's